In this video, we're going to explore the new combined links feature introduced in version 27 of MPanel Pro. To start building this, I've simply created a simple hyper, a square hyper, and copied this 3 times to form a model of 3 sails. These will be corner links, and this is a 3D polyline representing the fixing point. So I'll just change the color of this. So we've got 3 individual sails. These have all got 3D polylines around the outside, which I'm going to delete and replace these with individual lines. So we're representing a single cable supporting these 3 meshes, a single cable on the bottom side and on the top side. So here we can see the model after the 3D polylines have been replaced. So now everything, we have one 3D polyline. Again, I'll mark that blue. And these are all just AutoCAD lines. So I've made a copy, and we select everything, and we're relaxing this as a cable edge mesh, and we're using a link tension value of 20. And you can see this is a fully relaxed model already. Now we notice that we've got a reasonable catenary depth on the sides, but we've got a very flat catenary depth on the top and bottom edges of the sail. Now this is a function of MPanel determines the cable tension ratio for the top edge and the bottom edge from these endpoints. So instead of on the left and right sides, we have a clear end point for the mesh. For the top and bottom sides, it's reading the cable tension ratio as a ratio of this, the dip here to this span. Now we do have a tool built into MPanel for several years now to help overcome this problem. And here you can see I've added a 3D polyline to both the top side and the bottom side, and you'll see in the poly float constraints we've selected these 2 polylines and we've defined them as cable ends. So this clearly identifies this is the start and finish of the top side of this mesh for the purpose of determining cable tension ratios. And that applies to all 3. And when we relax the model again, we now get a decent catenary edge on both the top and bottom sides, as well as the left and right. And we can clearly see now the cable. This is one single cable acting on these sails. If we were to relax again using a different link tension, perhaps 40, we'll see we've got more tension in this cable, which is pulling the sails out further. Let's expand on this some more, and this time we'll do a series of 3 by 3 meshes. Same modeling method we used before, simply create one mesh and then copy the meshes together. Now the blue here is a 3D polyline representing the fixed points for these 4 corners. So we will model this as a cable, a cable, a cable, and a cable supporting all of these sails. Now, as we did before, we have to include a 3D polyline with the polyfloat constraints defined cable ends assigned. I've made a copy of this model here. We select everything and relax as a cable edge mesh, getting a reasonable solution, and we can see the same as this model here. The interior cables here are pulling hard on these edge cables and distorting the shape. So what we do here is we select all of these internal cables and Remember, these are all set to the same link tension of 10. We go to Extended Data, get the data, and we're going to override the value, and we'll make it 1. Relax again. We now get the model we expect. So we've got cable tension around the outside of 10 and on the inside a cable tension of 1. We could also make a copy of this and remove the internal cables. So model this simply as exterior cables supporting the sails. Relax again. We can see the edge cable tension ratio for the internal sails here is 1.6. 2 of those times 3 is influencing the edge cables some more. So we might increase the edge cable, the link tension, for the whole model. Step it up a little bit. And now we get the model we would expect. Thank you for watching. For more information, please contact support@mpanel.com.